Cool. So I think we have most people. Quick thing, I actually listened to my own video and my own the way I speak, and I didn't realize how monotonic I got. I'll try to address it, but as best as I can. No promise that it would get better. I've been trying to address this issue for the past, I don't know, 14 years, for a long time, and not sure. Well, I'll try my best to get better. All right. Uh, Today we'll wrap up everything related to the first two modules, which is Linux and C. Uh, if you look at the calendar, there'll be a discussion about the exam. We will talk about it today. Actually, I'll have a poll on, first of all, the exam format, and then another notice that I'm going to push the exam from next week to the week after, basically the 1st of June instead of next week, so that you get to look at assignment two and try some tasks over there. But before we move on, here are some recaps on Friday, because not everyone was here on Friday. I did post a YouTube video for the class on Friday, but at the end of the day, I think I want to make sure everyone has a recap, because Friday and today is probably one of the more confusing topics. All right, so we talk about data versus address. So if you declare something like int a equals 10, what is happening here is a is a variable, right? So that's the part that everyone understands. A is a variable. What is the data that is mapped to this variable? What is a storing? That's 10, right? If you put in ampersand a, because as I said, everything in C, everything in programming is associated with some location in the main memory. So what it means is A has to have an address, right? Uh, Once we are on module 4, you then understand that ampersand A is actually virtual address. We'll deal with it later. Just be aware that this is somewhere on your DRAM that you buy and plug on your motherboard. Whenever someone refers to memory, this is where A is. And ampersand A would give you the address. And the data associated with the address is 10. We talk about how to use pointers. Pointers are basically address. It stores an address to certain data. In this case, if you say int store a equals 10, a is basically a pointer that stores an address. This address, wherever it's located in DRAM, will have the value 10. The value 10 will be represented as binary, literally on a capacitor in DRAM. So if you print, right, so if you do printf, %d star a, you get 10. If you do printf %d a, you will then get the address. You will not get 10, you then get the address of this value. You can use ampersand to get this at the variable's address. You can then use store on a pointer to get its value. You can then make a pointer pointing to other variables, and you can also apply operations to pointer. A++ doesn't mean that I'm going to increment the value by 1. Depending on the type of the pointer, if it's to an integer, which is 4 bytes, then you increment this by 4. You point to the next integer. We talk about a now pointer. Basically, this is a pointer doesn't store any address. This is referred to as a now pointer, and in general, in C, this is equal to value 0. This doesn't really point to anything. It just tell the program that, hey, this pointer is not ready to be used yet. It is point to nothing. Data types: integer, character, floating point, long integer, double. All these things comes with different sizes. Each data has its own size. different sizes comes with different trade-offs. So if you've seen this new NVIDIA GPU that just came out, right? They have been declaring this new data type called TensorFloat 32, which is that's a bullshit way to name something, because in most cases the bits 32, 24, 64, all those numbers after the data type, usually those are how long the data is. NVIDIA just want to be different from the convention. So TensorFlow 32 doesn't really take 32 bits. We'll talk about that in the next few lectures on why it's bad for NVIDIA to do that, because it will confuse people. But then different data size has its own benefit. The smaller is faster. It makes your computer faster when you need to compute these things. In C, you can use size of, which is a command that check the size of the data type. For example, size of int means that I'm going to check what's the size of integer for this particular data type. So in C, that would get you 4. You can even put in the array. For example, size of A. If A is an array, it would then print you the size of an array. And then we talk about memory allocation, because think of it this way: whenever you need to use the data, I always compare this to an actual address physically around the world, right? So if you want to build a house, you need the land. Allocation means that I'm going to go and declare this is my land so that I can build a house, which means that I'm going to store data in it. There's a type called static memory allocation. This happens when you declare things like an array, things like you write in a function. The function actually takes some space on your main memory or DRAM. There's also dynamic memory allocation, which is done through a command called malloc, which is shown in this example. Basically, when you call malloc, what happens is whatever numbers that goes in here, it will talk to DRAM. There's a unit called memory management unit that would actually go and find empty space in DRAM or find the empty LAN for you to build a home, right? It would find that exact size or something bigger, so you can actually store your data in that. And then you can use that allocated space data. And as I said, think of it as basically you have a LAN and you want to fit, say, 10 integer. So you talk to this memory management unit, say, hey, I want a LAN big enough to fit 10 integer. They'll give back the address to that LAN. And that's it. As simple as that. What are the use of pointer? As I said, is for dynamic memory allocation. For example, when you use a program, initially you thought that you need an array of size 10. All right, perfect. Then you allocate an array of size 10. But after you run the program for a while, this same array doesn't fit anymore. You need an array of size 20. Dynamic memory allocation allows you to reallocate, basically acquire a bigger land for you to expand the house from size of 10 to size of 20. You can then implement multiple data structure, which we discussed today. We can pass data into functions. We can pass data out of the function. We can use it to return a value that's more than one items. We can use the pointer to assign specifically to a function. We actually will get to this now. This is called function pointer. All right, so any questions about the recap of Friday before we go into function pointer? Yes, no? No? Okay. So as I said earlier, everything in programming, once you need to run it, all of the programs are stored in memory. That's true for every single language. This is how computer works. Programs is stored in memory. Data will also be stored in memory, no matter what the language. C allows you to actually point to the actual program using the pointer, which means that you can do something with it. Basically, you can declare a pointer not to a data, but then this pointer would then point to a function. This is called a function pointer, and here is the example. Let's say I first declare a function. This is just a typical function. What it does is increment, right? A by 10. Any question about this function? The first 3 lines? What it does, take input, produce an output. What's the output? A plus 10. It's super simple. The way I can use a function pointer is, I know that this function name is called func, right? F-U-N-C. And I want to declare a pointer to this function. So this is what I can do. This is what is this? Ampersand func. What will that give me? Everyone is so silent today. I see people coming in and out, and that's pretty much it. It is an address, perfect, right? Exactly. It is an address to a function. Basically, this point to where that function is inside the memory. Right? That's it. Think of it as function as a black box, right? This address is the entrance to that function. It's like the door into that function. And then I got that address, so I know where to go if I want to call that function. Basically, once you declare ampersand func, right? These give me address of func. This we need to find a way to type write some space. Basically, this will tell you that hey, the function takes integer and then produce right? Integer. In here is just the name. So this thing you can name it whatever you want. Right now, I just name it func underscore ptr function pointer. So this whole line, the way you think about it, it's a function pointer. That right. And then let me use different color. That takes integer produce right integer. Basically, that's it. You just declare the function pointer that specifically would take one integer and produce another integer. The way you use it is something like this. Here. You can call it again, the same function pointer, doing the exact same thing. You can even then change here 0 from 0 to 10, right? Which will then print, what will it print if I do func pointer 0, func pointer 10? I would then get 10, 20, right? The first function pointer calls, you pass in 0, you add 10 to that, you get 10. The second calls, you pass in 10, so the result will become 20. So what if I do this? Func pointer func pointer 0. What will I get here? Okay, so let me go back back to Thomas' question, right? Is a bracket, is a parenthesis around this function pointer necessary? If you know exactly how the star works, not really the case, but just to be safe, basically star is dereferencing, right? So when you do star func pointer, it first then convert it to a function. You put a bracket around it to make sure that, hey, that's a function. Whatever comes next is my input to the function. So it helps in a sense that what if you have array of function pointers? This is making the conversion a lot more clean, right? Because you can then declare an array of function pointers. The first entry do an add, the second one is a function to do subtract. That's a valid array. Okay, so having this bracket around the name, it helps in a sense that it reduces number of bugs that can happen. So this basically what does this do? First, evaluate, put in 0 as an input, func pointer added by 10, so you get 10. Oops. So you then get 10 here, right? 10, which becomes an input to another function call. So you get 20 as a result after all this thing combined. You get 20. All right. So any questions about this? Basically, it's a pointer to the function. It's actually safer to have this parenthesis around the store function pointer to make sure that you then dereference to get the function. Whatever is outside of this bracket becomes the input, and then it returns an output. All right. So some notes on function pointer. First of all, because a function is statically allocated when you compile the code, right? So when you compile the program, all those function is some form of memory address already. So you don't need to perform allocation. And the reason behind this is programs are statically allocated. You can then get the address of the function using the function pointer. Which also mean you can do a lot of bad things. When you want to hack someone else's machine, why is that the case? How many pieces of DRAM do you have for each computer? So that's the first hint. Can someone answer me that? Yes, exactly. It can point to the wrong address, but what's important is if you think about it, right, in your computer, you only have one main memory, one big contiguous chunk of memory. So this is basically what is inside your computer. Memory, right, for the entire machine. This is where program A is located. This is where the OS kernel code is located. This is where program B is located, right? So if you point the pointer to a wrong address, for example, if you're running program A and it somehow point here, right, this is not safe. Why is that not safe? Well, you are trying to point to the other program's function, right? Modern day machines, because we have virtual memory, which we'll cover at the end of this class, we can prevent, basically, this is not allowed. This is definitely not allowed. But back in the day, back a long time ago, this can happen. You basically point to the wrong address. There are attacks. There are attacks that, one thing that you can do. You can keep using the get s function that keep reading the string, right? That I said earlier that you when you read the string, you are looking for \0, right? The end of string. One thing you can do is to keep reading until, let's say, program A is reading more and more and more character, right? And it needs some location in the memory to store the string, the input string. You then overwrite everything here. You overwrite everything in the memory up to program B's own function. Then you can actually point the function pointer to this overwritten function so that you hack the system and run your own code. It's actually possible. If you want, I can make you do that lab. Actually, it is possible to do it. I don't really, for the sake of your sanity, and also because we do have a lot of assignments already. If you're curious about how to do it, contact me in the email. We can discuss about, okay, what's the basic attack? This is called buffer overflow. And it's one of the common attacks that hackers can do to your own machine. These days, it's actually a lot harder to do because how the OS, how the architecture improved to prevent anyone from doing this. Pointer can be an array, as I said earlier. This means that you can have array of function pointers, and these operate like a normal function. And many C libraries, for example, quicksort, right? You can actually perform sorting for your entire array using function pointer as an input. What is that function pointer do? It basically, you need to declare how you want to compare two items, A and B, which one is greater than and which one is less than. Basically, you need to declare that function, and then you can run quicksort. You can use it as a callback function. A callback function is something that you would call if certain thing happen. Basically, you have a function pointer point to a function that most of the time you don't have to run that function. But if this happen, run that function. In our exercise, it would be actually, we are not gonna go through a lot of function pointers. But in the future, basically, once you're done with this class and you somehow need to kind of like work through function pointers and still have confusion about it, I mean, I'm here and you know my email, so I don't mind actually like communicating and then kind of making sure you got the right information on how to use it. But also in Stack Overflow, you see a lot of questions about it, and hopefully those will also help you troubleshoot and find the answer. All right. So today, before we go into the in-class exercise, we'll cover the next big topic once now that we know pointers, right? We'll talk about data structure. And based on your poll, some of you might be taking the data structure class. Some of you might have not taken the data structure class. This might be the first time you heard about the terminology. Basically, data structure is a structure we use to store data in a different way. Many of you use array before. I think if you use Python, you're familiar with array. Array is one type of data structure. We can use it to implement. We can use pointer to then implement other type of data structure like linked list, tree. These allows you to actually point to the concept of my next item, right? So here are the general guidelines. Before we go into detail, here are the general guidelines. You declare a struct, right? Remember our old friend struct that would consist of the actual data, and then a pointer that points to the next item. optional. If you don't want to type in struct name, struct name, struct name all the time, you can use type def to declare a name. And then what you can do is then declare a pointer that point to the first items. Think of it as if you look at a linked list, this is the head, the pointer just point to the head, the first item. If you need to add more items, then you can use malloc to append new items. And then, well, first of all, we'll play around these whole concepts in our in-class exercise today and assignment 2. But here, I'm going to go through some basic concepts. Linked list. What is a linked list? A linked list is something like this. You have a piece of data, but then a piece of data should, because it's a list of things, right? It should be able to point to what's my next piece of data. So it should have somewhere to data 1, right? Point to where is data 2. Point to where is data 3. Point to where is data 4. And then point to nothing. So that's it, right? That's the end of my data. Think of it as almost you have this array of expansible size. You can keep adding more things in. You can delete things from this list, right? And then you also need a pointer to, usually we call this a head, right? That point to the first items. This is basically a linked list. How many of you would have never seen this before? Because if you've seen it before, I want to go a little bit quicker. But if some of you have not seen this before, type in now so I can go slower. 1, 2, 3, 4, 5. Enough time to type the word. I have not seen this before. So, okay, good. Thank you. Actually, if this is new for you, think of it as, what if I want my array to be having infinite size? I can keep adding things. This is called a linked list. A linked list basically is the same as I have the first item, A0. A0 would then be able to tell me where is A1. Then it should be able to tell me where is A2. It should be able to tell me where's A3. That's the concept of linked list. That's why it's called linked list, right? What is a list? It's a series of items. Link means that I'm going to connect them together. What is that used for? Basically, linked list, we use it for the case where if we write a program, we have no idea how long the array that I'm creating is. It might be 10 items, it might be 20 items, it might be 100 items. So, alternative method is to use a linked list because you can keep expanding. You can use also a linked list to implement more complex data structure. The concept of how you can implement linked lists, then you can use it to implement other data structure like a stack or a queue, which I'm going to cover all of them today, right? But I want to make sure you get some example using the most common example. And to be honest, a lot of time, if they want to test like basic data structure, this is a lot of, this will go to some of the interview for like internship or like a entry level programmer job. They might ask you how to modify things in the linked list. The convenience of linked list, for one more thing that's convenient is if you have an array. So this is an array, right? And right now, let's assume that, hey, everything in here is sorted. So I have number 1, number 5, number 6, number 8, number 10, number 12, and nothing else. That's it, right? But I still have 2 empty space. What if I want to maintain this sorted list, but I want to add the number 7 in here. What do I have to do?
Go to 1 5 6 8 until 5 are empty space and then put the new number in.
You mean you put 7 here?
Yeah.
It's not sorted, right? If I want to make sure this is sorted, what do I have to do?
find find the two number that 7 is between and then move 8 10 and 12 to
Exactly.
the
So this
left.
is what I need to do, right? I need to kind of like tell my program, hey, I want to add 7 here, but then I don't have the space to do it. So the next thing I need to do is I need to move 12 here, right? I need to move 10 here, so this becomes 10, and then I need to move 8 here, so this becomes 8. And then I actually can now put 7 here. So this becomes 7. Right? Any questions about how you can do this with an array? And yes, the grain fact like that's the correct, like definitely correct answer. With array, you can access any of these elements anytime. You know what is a of 5, right? A of 5. So this is a0, this is a0, this is a1. Okay. So if I want to say a5, 2, 3, 4, 5, this is a5. You can access a5 right away. With linked list, you then need to start from a0 and it asks, you need to then ask, where's my a1, where's my a2, where's my a3, where's my a4, and where's my a5 before you can access a5. So there are trade-offs between array and linked list. But let's go back to the benefit of linked list. So in this case, if I want to add 7, right, if I want to add 7 to an array, I need to move things 1, 2, 3, 3 times, followed by insert, right? So remove, 1 insert. That's quite a bit. What if I have a linked list, right? So if I have a linked list, this is what it would look like. What you would have to do is, well, you have a node starting with 1, right? Followed by 5, followed by 6, followed by 8, followed by 10, followed by 12. So this is the original data structure that we have, right? 1, 5, 6, 8, 10, 12. And we want to add 7. So basically what you do is, okay, 7 is a new person coming here and want to be somehow belong to this linked list. So we then go here, followed by going here, followed by going here. The same thing as when you have to access the array, right? You check if this is greater than you. And then once you're here, you know that, okay, I just need to insert myself here. Which means that one thing I can do is I don't even need to move around 8, 10, and 12. What I can do is this. So let me erase this real quick. And my laptop is also, okay. What you need to do, the first step is, well, 6, which originally now point to 8. You want that to point to 7, right? You want to insert 7 between 6 and 8. So now 6 would then point to 7. Then 7 point to 8. That's it. You do insertion and you're done. You don't even need to move around 12. You don't even need to move around 10. You don't need to move around 8. You can then insert 7 into a linked list right away. All right, so any question about the trade-off between array and linked list? I'm saying trade-off because each one of these data structure offer different benefits. The actual benefit, the actual analysis on what's good and what's bad, I would then rely on you taking the algorithm class. So we're not going to discuss about it today. For the purpose of we need to cover other things, and there won't be a lot of. That's a great question. C doesn't have a class. So actually that comes next. How do we create this node, right? So okay, in terms of the performance and memory analysis of array and linked list, you can either wait until you take the algorithm class and data structure class, or you can email me. I think basically we can talk about this offline through the email. I don't mind explaining what's happening. It's just we don't have the class time, the full class time to do this. But that's a great question. C doesn't have a class. And as far as if you have worked through linked lists and anything before, you need something like a class. We have something similar. This is called struct. So this is what we can do. We can create something called a node. It can be any name, to be honest. The name is it can be anything. What should be the data type in the node? Can someone tell me one data type? Any data type is fine. It's fine. Char, int. Okay, so many. Okay, all right. So that is one character, two ints. I'll just do that. Char a int. Okay, and one more boolean. All right, I can do that too. Int c, and then There's no boolean. There's a trick. Don't forget that we don't have boolean. Yeah. So okay, so that's our data. That's the data that goes into the node, right? What else? We need to have a way to tell a way to tell where is my next item. So this is what I can do. Basically, I just need a pointer that points to the next item. Okay. This is perfect. I have a struct that contains multiple type of data that whatever I want to put in. Then I just then have a way to tell where is the next item. Then one more thing that you need, right? You need to make sure that you can keep track of where is the beginning of my linked list, so I can do this. Right? I just need to declare a head right now. Right now it's an empty linked list. Okay. So I assign to now. If I want to create the first node, this is what I can do. I just call it temp, right? Equals new, maybe equals malloc. Right? This give me a LAN, and an address, right? That is the same size as one node. So this is what happened when I call this line. So first I have a head, right? That points to nothing. Now that I call the first line, so let's say this is the first line. The first line would do this. I would create this struct, right? This is char A, int B, and int C, and then you have this pointer point somewhere. What I can do next is I can say temp. So when you use struct, if you don't want to do the dereferencing, and if if you're using a pointer right now, because temp is a pointer, right? It's a pointer because I have a star here. I can use this arrow sign to refer to items inside my node. So because there's no next item, I can do temp next equal now. Then what's the next thing I have to do? So that's the second step, right? Second step is I say this is pointing to nothing. The third step is basically because my linked list has some items, so I can do head equal temp. So this would then get rid of this and now point head to the first node. Then you can keep doing the same steps to add more and more nodes. Basically, if you repeat the step 1 and 2 again, you then have head, right? That points to the first node. That will then the first node, then point to the second node. Would then can point to the third node, right? That can point to the fourth node, which then point to nothing. And now you have a series of nodes. Each one of these is a struct that consists of a character to integer, and then that pointer that points to the next item. Any questions before we go into the next type of data structure? This is actually almost similar to a linked list. All right, so how do we input data into the linked list? That's also a great question. So right now we have temp, right? We can modify the content by pointing the pointer to the something. So if you want to say assign the value to A, this is what you can do. Temp A equals, I don't know, letter B. You can then do temp B equal 5, and then temp B equals 10. Right? So you can, because you have this pointer called temp that point to some nodes in this linked list, you then can use this arrow sign that would refer to one of these variables inside the linked list. It can be A, B, C, or next. Then you assign the value. All right. So let's talk about a queue. What is a queue? It's something that all human beings should follow when you have to line
Q
up.
Q is a Q.
Queue is a queue, yeah.
The first element can only be taking out, and we put when we put it in at the back.
Yes, exactly. Sometimes I call it being nice. Basically, it's called first. Sometimes we will refer to this as first in, first out, right? FIFO. The first item that go in should be the first item that go out. You can use a linked list to implement the queue. You can have the head, right? Oh, that points to a queue. And we call the last one tail. The tail basically is the last item in my linked list. Then I would then know where's the head, where's the tail. You can then also, I mean, to be honest, you can use an array to implement the queue too. You can also then say, I have an index that represents the head. And the tail. When you enqueue, which means I add one more things to the queue, right? So the two old versions of a queue is enqueue, which is basically means that you add something to your queue. And then DQ, which means that I'm going to remove something out. So my question, in C, if I need to NQ, where do I put the next item? Is that at the head or at the tail? Yep, exactly. You add the item at the tail. If you need to DQ, you remove the items at the head. It's as simple as that. The queue, if you use a linked list, you can keep growing. If you use an array, sometimes the queue gets full because an array has limited size. So you need to then double the size. The trade-off between a linked list or an array is whether you want a limited size and a little bit slower. Or you can use an array just to be faster until you run out of the space to put the new item. So here's what you can do in C for a queue. So I'm gonna use an array. This time I'm gonna use an array, right? Basically, let's say right now I have a queue of size 20. Each one is an integer, so I can do this int queue. It can be any name. Basically, now I'll name this queue. And then int head, int tail. When I need to initialize everything, what do I have to do? I can do this. Head equals 0, tail equals 0. Right? The queue doesn't have anything, so a head and a tail is at the same location. Perfect. It's a queue of size 0. What if I want to have a function that checks if my queue is empty or not? What do I do? Oh, God. I can actually do just this. Return head equal tail. Well, yes. And a cheaper way to do that, because we assume that if head and tail is at the same location, it means there's nothing in my queue. So I can check if the queue is empty by checking if head and tail is the same value. What if I want to NQ? By adding A into my queue. Well, first of all, the first thing you need to check is if the queue is full, right? We are not going to implement this whole thing because we will not have a room to write everything, but let's assume that there's also another function to check if the queue is full. Then what we can do when we want to NQ deals with the tail, right? So we can do this, queue tail equals A. Tail plus plus. Right, we increment the tail by 1, so now originally it's something like this. Head, tail. Right. Once you insert A into this is what happened. You have A here, and then tail is now here. What is the next thing you want to double check? Basically, if tail is greater than or equal to 20, right, it needs to go back to 0. That's because your queue is not unlimited. So if L is greater or equal to 20, because that's the size of our queue, L equals 0. And that's for NQ. For DQ, the same process. Basically, instead of putting A into the array, then you return whatever head is pointing. Then increment head, if it's greater than 20, then you revert head back to index 0. Any questions about how we can implement a queue in C? So we will then talk about something almost similar to queue. It's a stack. If you have not heard about the stack, instead of first in, first out, we call it first in, last out. You keep putting things in. When you want to take items out, you grab the last items. Think of it as something like this. Right? You put items in here, A, B, C, and D. The process of putting things in, we call this push. Push A, push B, push C means that we add the new items into my stack. Push D. If I want to take things out, I call pop with nothing, right? Basically, pop would then look at the stack, grab whatever is the last item, return. So pop would then give you D. Any questions about the difference between a queue and a stack? All right. What can I use a stack for? Actually, there's a lot of things in system. Not lost. Lots of this. A lot of system tasks kind of rely on the stack. Parenthesis mapping is also a stack. Basically, if you have something like this, this is not legal, right? Because I missed this one single n parenthesis and also two more n parentheses. You can write a program to check if the parenthesis mapping is legit or not by using a stack. Every time you have the open parenthesis, you push. Every time you have a closed parenthesis, you pop and check if the item coming out is the same or not. So I will go through this example quickly. This is what I would do. If I have a stack, I would do something like this. So this is my stack, right? The first thing I put in is this open bracket, followed by open bracket, right? Because it's all open parentheses, followed by this, followed by this, followed by this, right? And then now I'm here. Because it's the end of this parenthesis, I pop and I see, okay, this is my most recent parenthesis. This is what I'm comparing to. This is legal. That's fine. Yay. Then we pop this and check if it's the same as this closed bracket. We pop, right? We have this and then this. This is illegal because we want the normal parenthesis, not this bracket. So we can tell that this is not a legal parenthesis mapping. You need to add this close parenthesis, not the the bracket. All right. And then once we pop until everything is there's nothing in the stack, then your whole line of tons of parentheses is valid. It's the correct way to open and close parentheses. You can, oops, my bad. You can then implement a stack in C, as I said, again, using an array, right? So you can have array of size, say 20. Right? And you don't need a tail. Basically, you just need a head. This is telling you that's the location of where is the top items. When you do push, right? Void push int a. This is what you can do. ARR of head, right? Equals a. You add a into this, and then you do head. I don't know why this always happens in PowerPoint. If any one of you know why sometimes I write and it doesn't show up, let me know. Basically, you can do head. Oh my god. Alright, I will stop fighting this. But you know it's a head plus plus. This is tiring. That's it. That's when you need to do when you push, then you just need to make sure if head is greater than the size of my array, right? Check if head is greater than 20. Because if it's greater than 20, it means the stack is full. That's it. Int, you can do a pop, right? Pop doesn't take anything as an input. You just want to get the most item, the most recent items out. In here, head will point to the first empty location. So if I need to pop, if head is 0, it means that this is not valid. You're popping something that's empty. You return. I guess you return now, it's fine. Else, you then return ARR minus head. So I have one quick question for you. What's the difference between head plus plus and plus plus head? Have any one of you noticed that you can do plus plus or minus minus at the beginning or at the end? The only difference is when you do head plus plus, it would do as the last thing on that line. If you do plus plus head, this is the first thing you would do. You first increment followed by doing whatever is on that line. So here I have ARR of minus head, right? Followed by a return. This is the first thing the program would do. Then it would do this. This is the second thing. Followed by this whole return. This is the third thing. It would then decrement head, return the array items where head is pointing, but you already decremented, so you still get the correct value. All right. Then we talk about stack. The next item that I want to talk about is the binary tree. But before we go into binary tree, I want to talk about what's a tree. I assume that because some of you never heard of linked list, some of you will also never heard of what is a tree in computer science. So what is a tree in real life?
the data type that start from root and then it just branch out into other point that branch out into other point.
Yeah, but let me kind of go back to a real life example, right? A tree is an object that have branches, right? Each branches can also branch out into multiple branches. So if you want to look into how to store data in this way, this is what happens. You have the first object. The first object then branch out into any number of objects, which can then branch out into any number of objects. This is a tree. A tree has a direction from top to bottom. Right? Whenever you branch out, this is called a root. Root is the first node. This is the same thing as Linux directory. You have the root, right, that slash. Every single directory under the root belongs to the root. You can trace the step from the root to anywhere. There's a parent and child relationship where the parent will point to a child. The child is basically whatever nodes come after the parent. So a root is a parent to node A, node B, node C. Node A is the parent of node D and E. Node D is the parent of node F. Node C is the parent of all the remaining nodes here. Right? Any questions about the tree? Basically, it has a root. A root can spawn any number of child. And then any number of childs from the root also can spawn any number of childs. It can go any number of levels. It has direction from the root down to the leaf, right? We call these child, like basically the last level. These are our leaf. All these things are leaf, right? These are all the leaves. This is basically is a tree. What is a binary tree? What does binary mean? Binary means that there are two. So a binary tree means that when you branch out, you can either go left or go right, and that's it. You have two shelves. You can have up to two shelves. So it would be something like this. This is a binary tree. Because every single node here has up to two shelves. Right? So if someone tell you, okay, what's a binary tree? It is, as I illustrate here, I have a root. A root can have a child. Every single node here can have up to two childs, two children. My bad. Sorry about the English. Up to two children, and that's it. All right. The example here, this is not a binary tree. Why? Because the root and node C has more than two shelves. Usually, we would refer to this, the left direction as the left. And this is the right child. So you would then refer as the left child and the right child. Right? Binary tree has so many use in computer science. You can sort things using binary tree. You can search using binary tree. Indexing and file system, where it tells exactly where is the file located on the hard drive. is also done through some form of tree. It's not exactly binary tree anymore, but it's a tree. So this is one of the most important data structure that you see it again and again and again and again. If you've seen this for the first time, it's okay. You you see this for so many times, you can used to it at some point. Basically, if you want to implement the binary tree in C, this is what you can do. In a linked list, we have a struct, right? And let's do the same thing. We have character A, int B, int C, right? These are the data that go into the node. What is the difference here is it's not the next item anymore. So what you would need is where is my left child and where is my right child? So you would have to do this. Struct node store left. And that's it. That's how I can declare, hey, it's a node that contains the data A, B, and C. And then the node also contains a pointer, 2 pointers to the left side and the right side. Right? Think of it something like this. A and B and C is here, and then you have left, and then you also have right, which then can point to another node, which has its own left and right, which can point to more nodes. This can also point to another node, which can point to nothing. And when I write in this is basically null. All right. And instead of having a head, right, then you have a root that point to the first node. So you can do struct node star root. And then you use malloc to keep creating these nodes one by one. We would then do this both on the assignment and some of it in the in-class exercise. In class exercise, we're not gonna do, I don't think we do the full-blown tree. So one thing that I definitely recommend once the assignment 2 is out, try it. Definitely try to do this before the exam because we'll actually have a review session and we can go into a lot more depths that's specific to your own question. Right? For the reference, this is the same reference I put on the last time. I have posted in-class exercise that kind of talk about today material. And today material would also include things like dynamic memory allocation. This time, it might be a little bit more fun, and this credit definitely go to Ajahn Gridya. Like basically, she kind of developed this whole in-class exercise on Hacker Rank, which allow you to submit the solution, and it would grade if it's correct or not, and then you can then look at your own implementation and play around with it. You can actually compete amongst your friends in the class. I am keeping this in-class exercise open until the last day of class. So feel free to kind of keep submitting, playing around with it. One more thing, assignment 2 is out tonight. How many of you finished assignment 1? And how many of you still need to finish it? Great. So do you all plan to use it later? Kind of lost. Okay. If you are kind of lost right now, it's a good time to email me and trying to figure out how to do X and Y, Z. One more thing. Because it seems like every one of you need more time. I'll do this. For those of you who finished already and want to submit, you get extra credit. For those of you who need more time, I'm gonna give until Wednesday night. If you submit by Wednesday night, you don't have to use the token for late days, but you don't get extra credit. And the extra credit, you get 10% on, basically, let's say you submit tonight and you got 80 out of 100. Extra credit will apply 10% off the 80, you will then get 88 of 100. If you submit on Wednesday, you don't get any of that. Is that fair? For those who submitted or ready to submit, wait, oh crap. Is it due next week? My bad, let me go to the class assignment page. Okay, yeah, due next week. My bad. Okay, reword everything. 25th, that is correct. Sorry. For some reason, I thought it was due this week, and I was kind of panicking. All right, I'm sorry, everyone. Assignment 2 is out tonight. Okay. My bad. It's due next week. Next week. I'm so sorry. Okay. All right. Well, definitely got your attention. Yes, and chat heat it up. Okay. I'm sorry. Assignment 2 will also still be up tonight, and you have from today. I think I screwed every. Basically, then instead of 3 weeks to work on assignment 2, you then have 4 weeks. Because I kind of somehow I thought assignment 2 supposed to be out today, and then assignment 1 supposed to be due today. My fault. Basically, assignment 2 would be up today, but you have 3 weeks after assignment 1 to finish. The reason I want to release it now is because we do have exam coming up, so I definitely recommend you to go through the question. All right, so everyone is on the same page. Assignment 2 is just 2 weeks after assignment 1 is due. Okay, 3 weeks after assignment 1 is due. Is this a longer assignment because it includes everything about C? And we did spend more time on C than Linux. The weight is assignment 2 would be words, 50% more because it actually supposed to take 3 weeks on top of assignment 1. All right. One more thing, exam is coming up, but well, first of all, the material is up to today. Shell scripting and C, because we will start to move on from this C topic and go deeper into how do I represent data, what is assembly, all those things. So anything up to today's lecture is a fair game on assignment 1. The original plan on the calendar, which I will fix, right, is it's supposed to be next Monday. This is a bad idea because you haven't really tried assignment 2 at all. So here is my proposal. Exam will be on June 1st. Review session will be on the 27th, Wednesday before the exam. We will continue on data representation and assembly this Wednesday. Those would go into the final. Anything for this exam 1 is up to today. Anyone have a question about this before I send the next question to you, which is the poll about the exam format? Basically, exam 1 will be on June 1st. I will have a review session next Wednesday. definitely recommend you to check out assignment 2. That's why I want to release it today. All good? I am opening a poll about the exam. So if you click on the poll, I put in 5 minutes. So it asks about the exam format and everything. Just because there's no way for me to check if you open anything on your screen, I would need to make it open everything. You can search the internet. I'll make the exam a little bit more open end. There is likely to be the question that asks you to design something. And the answer would then focus on why you choose certain things over another. And quick warning before you keep putting on 3 days time limit. If you put in 3 days time limit, there'll be a lot more things to work on. So the tasks that I'm gonna make you do will expand based on the number of hours going into the exam. So if it's 3 days, there might be more questions. If it's 24 hours, there might be more questions than 2 hours. If it's 2 hours, now I see a lot of people put 24 hours. Personally, I think 24 hours makes the most sense because you have time to think about every single question. It won't be super long. It definitely will not be super long. I would make sure that the exam you should be able to finish everything within maybe 3 to 4 hours. I will make sure definitely you can finish in 24 hours. And it seems like, right, so 24 hours win. The exam would be 24-hour exam. I would release it on June 1st at the beginning of the class. We will be meeting here. If you go and read the question and you have anything related to the question that are asked on the exam, you can ask during the exam time. Basically, I'll be here as a proctor for 2 hours. You can ask the question through the chat. You can ask the question loudly by turn on your microphone so everyone can also check if that question, if you have the same question too, right? Uh, it might be slightly chaotic, but it kind of worked with OPL when I teach last semester when we need to abruptly change to an online format. So I hope it works this time. All right. So now that we have enough people to vote on 24 hours, so I'm gonna close the poll because we have more than 50% that say let's do 24 hours exam. So let's move on to the in-class exercise. I'll be around. I just need to come back to my desktop setup. This is the end of the lecture. Please check out the in-class exercise because it involves topics that we teach on Friday as well as today. And that's it for the lecture. If you need to go, please be aware that in-class exercise won't be closed for a long time. So make sure you do it. My recommendation, do it now because I'm around. You can ask me the question anytime. Okay, so a few of you asked if I can move to June 3rd. If you're still here, let me open another poll between June 1st and June 3rd. I mean, I don't mind between the 2 days. Let me create another poll. Okay, exactly. Okay, open the poll, June 3rd or June 1st. And somehow I feel like everyone would. Okay, this is interesting. Wow, this is a nice competition between the 2 days. All right, it's 4-4 right now. So one quick thing, if you actually have a conflict that legit reason, say for example, you have 3 other exam on June 1st, and you don't want to have the exam on June 1st for the third or the fourth exam, that is a totally legit concern. So you can let me know. We will figure out what to do with it. Basically, I don't want to overburden you with additional third exam or the fourth exam or the fifth exam. That's not good for any one of us. So if you have that concern, let me know because I am willing to have 2 different copies of the exam 1A and 1B. And then June 1st, folks would do 1A, June 3rd, folks would do 1B. But you need to let me know. If you, as I said, if you have conflict, I'll keep it open until next week, next Monday, to tell me so we can figure out what's the best thing to do. All right, there are 6 more of you that need to vote. This question is it's a close competition. So you can go lobby your friends to vote on some of the questions here. Right now, June 3rd is winning by 2 votes, and 6 of you haven't answered. I would leave it open for maybe a minute or two in case some of your friends are sleeping or not up or cannot vote or for some reason didn't see the poll. Uh, okay, because the 2 dates are so close and some of you kind of basically tell that hey, there's another exam on the same day. I would actually make a Google form for everyone. I'll send it out maybe on Wednesday, and I'll let you take time to tell me if you have exam conflicts, right? That I hope that's fair for everyone. As I said, I don't mind coming up with 2 versions of the exam that you have to work through. Uh, June 1st group would take one one version. June 3rd group would take another version, and I'll somehow grade it. Uh, and I hope that's fair. Basically, you then have choices between between the 2 dates, and hopefully you know which one is a little bit better for you. All right. So let me close the poll because the result is super close. And here are the results, right? It's still unknown. It's likely that if there's an exam conflict, I would just do the 2 versions. All right, so let me save the slides and move to my desktop setup and post the slides. The video of this class, as I said, we posted on YouTube. top is also